Hey everybody, we're getting ready to do lesson 10.3 part 1, grade 6 math today. And for 10.3 part 1, generating equivalent expressions, you got 59 points on your classwork sheet. Have that out in front of you now, students. And you got 4 points on your notebook guide or your notebook, 4 points there. Name, date, period, students, on your sheets. So when I grade it, I know who to give a grade to. And then due date here for my onliners and homeschoolers. So let's go right in to our essential question. How can you identify and write equivalent expressions? So that'll be in our Explore Activity 1, identifying equivalent expressions. One way to test whether two expressions might be equivalent is to evaluate them for the same value of the variable. That'd be one way to determine that. So page 2, match the expressions in list A with their equivalent expressions in list B. So that'll be list A, we got 5x plus 65, 5 times quantity x plus 1, and then 1 plus 5x. And then for list B, we have 5x plus 1, 5 times quantity 13 plus x, and then 5x plus 5. So which one of these matches up here between list A and list B? So list A will be equivalent to this one here, the first one here, and then this one will be equivalent to this one here, right, students? And then this will be equivalent to this one up here. So that's what we're talking about, equivalent expressions. And then part A, or evaluate each of the expressions in the list for x equals 3. So we'll have a list A here, 5x plus 65, and then we're going to plug in for x, we're going to plug in 3 for that, plug in 3 for that, plug in 3 for that. So for list B here, so 5x plus 1, 5 times quantity 13 plus x, and then 5x plus 5. One way to test it is to plug in a value here for x, and then to check whether our selections in the previous slide are correct. So to do that, 5x plus 65 equals what? And then 5 times quantity x plus 1 equals what? And then 1 plus 5x equals what? And then over here on under list B, 5 times quantity x plus 1 equals what? And then over here, 5 times quantity 13 plus x equals what? And then 5 times quantity x plus 5 equals what? So for this here, 5 times 3 plus 65 equals 80. You should have that. And then 5 times quantity 3 plus 1 equals 20. Because 5 times quantity 3 plus 1 equals 20. And then 1 plus 5 times 3 would equal 16. And then over here, 5 times 3 plus 1 will equal 16. So these two here are the same. They're equivalent. And then 5 times quantity 13 plus 3 will equal 80. So these two here are equivalent. And then 5 times 3 plus 5 will equal 20. So these two here are equivalent. That would be how you would check it. B, which pairs of expressions have the same value for x equals 3? And we went through that previously. See, and then C, part C of that. And then for students, I want you to write this down in this space here. We determined that in the previous slides. And so determine which pairs of expressions have the same value for x equals 3. And then C, how could you further test whether the expressions in each pair are equivalent? So what would be a further test for that? And then put your answer here for that. Teachers, give your students about 3 or 4 minutes for that. And then for D, do you think the expressions in each pair are equivalent? Why or why not? And then put your answers here, students, for that. And then teachers, again, give your students about 3 more minutes for D for that one. And this is 9 points here for page 4 of today's classwork. lesson. And then for up here, which pairs of expressions have the same value for x equals 3? 5 times quantity x plus 1 and 5x plus 5, 1 plus 5x and 5x plus 1 and 5x plus 65, and 5 times quantity 13 plus x. So basically all of them are equal for when you plug in x for the same value that survives that first test. And then C down here, how could you further test? How could you further test whether the expressions in each pair are equivalent? Sample answer, evaluate for several other values of x. So you could plug in other values up here like fractions or negative numbers. You could test those to see if they are still equivalent. And then for D down here, do you think the expressions in each pair are equivalent? Why or why not? So the sample answer will be yes. It appears that they will always have the same values. So for most integers that you plug in here, unless you start getting into other kinds of numbers, non-real numbers, they seem to be always have the same value. So explore activity 1 and continue reflection here, reflection time. Error analysis. Lisa evaluated the expression 2x and x squared for x equals 2 and found that both expressions were equal to 4. Lisa concluded that 2x and x squared are equivalent expressions. How could you show Lisa that she is incorrect? So if you only go so far, well, I'm not going to answer it, students. I want you to answer that here. Teachers, give your students about 2 minutes to answer this up here. And this is a great point here, a great point. And then evaluate the expressions for different values of x. For example, when x equals 1, 2x equals 2, and x squared equals 1. So if you get into exponentials and that kind of a thing, you kind of get a different picture after you do that. So really not for all values. Okay, moving along here to explore activity 2, modeling equivalent expressions. You can also use models to determine if two expressions are equivalent. Algebra tiles are one way to model expressions. So using algebra tiles and algebra tiles. What in the world are algebra tiles? So this thing here will equal 1. We just have a plus, kind of a plus sign on a yellow tile. That would equal 1. And then a plus tile here with a larger, it's a larger rectangle here, that would equal x. So the smaller tile here would equal 1, whereas the larger tile will equal x. So using that kind of premise here, determine if the expression 3 times quantity x plus 2 is equivalent to 3x plus 6. So A, we're going to model each expression using algebra tiles. So using algebra tiles for this, 3 times quantity x plus 2, and then 3x plus 6. Now, does this equal this? And we're going to use algebra tiles. So we have this tile here for an x, and then this tile here for an x, this tile here for an x. So we got 3 times x. So here's our 3 x's here. And then we have 3 times 2 here. So 3 times 2, we have 1, 2. This is 1, 3 times 2. And then this is 2, 3 times 2. And then this is 3, 3 times 2. So now we have 3 2's here, right? 2, 2, and 2. So we have 3 2's and then we have 3 x's. So does that equal over here 3 x's? So 1, 2, 3, 3 x's, and 3 2's equals 6, right? So we have 3 there, then 3 more there. So we have 6 of the 1 tiles and 3 of the x tiles. So if you use tiles, they do appear to be the same, correct? So 3x plus 2, here they are in tiles, and then 3x plus 6, these are the tiles over here. After you distribute your multiplication here, this is what you get. And if you just write 3x plus 6, does this equal that? And it seems like it does. So the model for 3 times quantity x plus 2 has blank x tiles and blank 1 tile, students. So fill that in. Teachers, give your students time to do that. And then for the model for 3x plus 6 has blank x tiles and blank 1 tiles. So for this one here, 3 times quantity x plus 2 has blank x tiles and blank 1 tiles. And then the model for 3x plus 6 over here has blank x tiles and blank 1 tiles. Now, C, is the expression 3 times the quantity x plus 2 equivalent to 3x plus 6? Explain. So on this page here, teachers, give your students about 2 or 3 minutes to fill in the blanks here, and then provide the solutions here for this. So the model for 3x plus 2 has 3 x tiles and 6 1 tiles. 3 times quantity 3x plus 2, right? You got 6 1 tiles and then 3 x tiles. And then for this model over here, 3x plus 6 has 3 x tiles, 1, 2, 3, and then 6 1 tiles, 3 and then 6. So is the expression 3 times quantity x plus 2 equivalent to 3x plus 6? Explain. So yes, each expression is represented by 3 x tiles and 6 1 tiles. Correct? Yes, everybody agree? Okay, we're going to think about that a little bit. Use algebra tiles to determine if 2 times quantity x plus 3 is equivalent to 2x plus 3. Explain your answer. So for this set up here, these two different expressions here, are they equivalent? Teachers, give your students some time to reflect and think about that. And then down here, we're going to provide an answer here using tiles. 2 times the quantity 2x plus 3. So we have x here, and then 3 tiles here, one set of 3 tiles, and then a second set of 3 tiles over here. And then down here, 2x plus 3. Does that equal this up here? So we have 2x tiles here, and then we have 3 tiles here. So is 2x plus 3 equal to 2 times the quantity x plus 3? Does it look like these two expressions are equal to each other using tiles? No. 2 times quantity x plus 3 is represented by 2x tiles, and 6 1 tiles. So we got 6, we got 3 here, and we got 3 here. That 3 plus 3 is 6 1 tiles. And then down here, 2x plus 3 is represented by 2x tiles, 1, 2, and then only 3 1 tiles. So by using tiles as a visual representation of these expressions, you can only tell that no, 2 times quantity x plus 3 is not equivalent to 2x plus 3, is not. So they are not equivalent. And that is part 1 of 10.3 grade 6 math. Animated PowerPoint math video at AOL.com for questions or course materials. Thank you very much.